Hi all, we are studying the subject information theory and coding, and in this information theory part we completed, that means what is an information and what are the related mathematics we can use in this concept information, all the things we studied. Now we can see what is error coding. So in that first we can see what is an error dictation and error correction code. So we know that we have different coding techniques are there. That means variable length coding is there and fixed length coding is there. So in case of variable length coding, that affect more than one block code. If any errors if any noise is present, that will affect more than one block code word. And also this output data rate over short period will fluctuate widely in case of variable length coding. So if you are considering a fixed length code, a single error will affect only that block, which can be easily detected and corrected. So to detect and correct errors, we use error control coding techniques. So in fixed coding as well as in variable coding, we know that if we are transmitting the information through channel, there should be error, and in to detect and correct that errors, we need some controlling mechanism, and that is called as error control coding techniques. So error control coding is also known as channel encoding. So previously we studied what is information, how we can code the messages. Now we can see how we can encode our channel. So that is a channel encoder is used to error control coding at the transmitter, and we are using a decoder at the receiver. So now we are going to study what are the coding techniques that used for channel encoding as well as decoding. So we can see what is the advantage of error control coding, that improve the data quality and also reduce the noise for a fixed bit rate, thereby reducing transmitted power and hardware cost. And the disadvantage is that it increases the bandwidth requirement as well as system becomes more complex due to implementation of decoding operation at the receiver. So these are the disadvantages and advantages of this error control coding. So the channel encoder at the transmitter systematically add digits to the transmitted message digits. These additional digits carry no information but make it possible for the channel decoder to detect and correct errors. So we can see how this error control coding techniques will work. So in that case, the channel encoder will add some digits, extra digit in addition to this information digit. The channel encoder will add some extra digit to the transmitted message. Basically that extra digit doesn't carry any information, but at the decoder side, that that extra digit will use to detect and correct errors. So the additional digits which carry no information are called redundant digits or redundant bits, and process of adding this digit is called redundancy. So in case of channel encoder and channel decoder, what do you mean by redundancy? Means the process of adding extra digit to detect and correct errors is called as redundancy, and that extra added bits are called redundant bit or redundant digits. So we can see what are the error correcting codes are there. So next class onwards we can study what are the different error correcting codes. So the main classification is based on the memory. So whether the code have memory or whether it is memoryless. So based on that we have two classification, that is block code and convolutional code. So in block code there is no memory, and that means present channel output is depend on present input only, but the convolutional code which have memory. So based on that we can see this codes in detail later. So now just remember this error correcting codes, we have two types, that is block code and convolutional code. So we can see the block diagram of error control coding. So we, after finding the error, if we detect error, we need to control that error or we need to correct that error. So we can see how this error control coding works. What is the block diagram of this error control coding? So we have a block of k message bit is there. So we need to send that k message bit without any error. So after this we are receiving this k message bit and we are giving that to channel encoder. So this channel encoder will convert that message into a coded output by adding some extra bits to that message bit. So already our message have k bits and this channel encoder will add some bits. So the output of this channel encoder is n code words. That means this n code word consists of k message bit plus n minus k check bits or redundancy bits. It's also called as check bit. Then we are modulating that coded output. Then that will transmitted to the channel. So at the receiver side, this demodulator will demodulate that message and they will get this n bit code word. So that is represented as dk dash. This from this n bit code word, that means demodulated code word, the channel decoder will generate the output message which consists of k bits. So here we can see that we are adding some extra bits, that is n minus k check bits, and that n minus k check bits is added by the channel encoder, and at the receiver side, using this n minus k check bits, the decoder will check whether error happened or not. So we can easily dictate the error as well as sometimes we can correct some errors also. So we can see what is a channel encoder. So channel encoder add n minus k number of redundant bits to this k bit messages to form n bit code word. This n minus k number of bits are called check bits, do not carry any information but helps channel to dictate and correct errors. And the bit rate of the code output block we can represent as dk will be rc is equal to rb into n by k bits per second. This is the rate at which a modem operates to produce message block dk dash at the receiver. Then we can see what is channel decoder. So channel encoder, we said that it will add some check bit to this message bit and with the message bit and produce encode word or encoded output. So channel decoder will collect this coded output and then decode to get back the information block, that is bk dash. So we send the decoder will accept the dk dash and then from that it will generate the bk dash at the receiver. So bk dash may differ from bk due to error. So this bk is the message that we send, but the bk dash is the message that we decoded. But sometimes this bk and bk dash is different. That means there should be an error. So to find this error, to check this error and to correct this error, we are using that extra bits that added by the channel encoder. So the probability of error p is represented as p of bk dash not equal to bk. So we can say that there should be a probability of error if bk dash is not equal to bk, and this value of probability of error must be less than prescribed value. Probability of error qc of the modem is qc is equal to p of dk dash not equal to dk, and this qc depend on rc. So that is channel decoder. So without error control coding, qc will be much higher than desired value of probability of error. So error control coding is necessary. So we said that if bk dash, that means our decoded message is not equal to the bk, then we can say that there should be error. So to limit that error, we are not saying we can completely remove the error, but we can limit the error using this error control coding techniques. So we can see what are the types of errors. So there should be random errors and burst errors are there. Then that is the type of errors that will happen to this encoded messages. Next we can see what is a linear block code. So that's the first topic coming under error coding. So we already said that a block code consists of k message bits and n minus k check bits. So in this channel encoder will receive this k message bit and it will add n minus k check bit. Then we are sending then we are converting that into encode word. So that is a block code. So we can see that the block code consists of message k bits, and there should be a channel encoder, and that will produce a code word which consists of n bits, and in that k message bit and n minus k check bits are there. So this message bit may be in the MSB or MSB side, and this check bit may be in the LSB, in that case LSB side, and sometimes the check bit in the MSB side and the message bit will be at the LSB side. So if it is possible to differentiate the message and check bit, then we can call it as a systematic code. If it is mixed up, that means we can't identify what is the message and what is the check bit, then we can call it as a non-systematic block code. So we can see here there is a channel encoder that will accept this k message bit and generate a code word which consists of n bits, and in that n minus k bits is called as check bit. So we can see that this we already said that channel encoder block of k message bit is encoded into a block of n bit by adding n minus k number of check bits. Such a code formed is called as n by k block code. Next we can see how this block code act as a linear block code. So this n by k block code is said to be an n by k linear block code if it satisfies one condition. The condition means let Z1 and C2 be any code words having n bits belonging to a set of n by k block codes. So we have a block code, it consists of so many codes. In that we are taking two code words C1 and C2. Then if you are adding the C1 and C2, that output is also an n bit code word that belonging to the same set of n by k block code. Then such a block code is called as n by k linear block code. So in this linear block code, if you are added any two code words, you will get a third code word that will be in that set itself. So if it is if two code words added, then the third code word is not in that set of code word, then we can say that it is not a linear block code. So the condition for a block code to be linear block code means if we added two block codes in modulo 2 addition, the third code word, that generated code word, will be within that set of code word itself. Then we can say that it is a linear block code. So a block code consists of a set of code words. In that we are taking two code words, then we are adding in them in modulo 2 addition. Then the resultant code word should be in that set of code words. Then we can say it as a linear block code. And thus we know how we can represent the modulo 2 addition. Modulo 2 addition symbol is a plus symbol in a circle. So, and we can also see that in case of 0 and 1, the modulo 2 addition, in case of binary, the modulo 2 addition is XORing itself. Then we can say that systematic linear block code means a k message bit appear either at the beginning of the code word or at the end of the code word that we seen in this figure. So that is called a systematic block code. Otherwise it is called a non-systematic block code. So that is linear block code.